Example 2.5. A car traveling at a constant speed of 24 meters per second passes a trooper hidden behind a billboard, as in figure 2.17. 1 second after the speeding car passes the billboard, the trooper sets off in a chase with a constant acceleration of 3 meters per second squared. Part A, how long does it take the trooper to overtake the speeding car? And Part B, how fast is the trooper going at that time? Alright, I'm going to start this problem by drawing a plot. Now I've got a huge advantage in doing this problem because I've seen it several years in a row. But the way I'm going to do it, I find this is a nice way to see it. I'm going to give a plot of x versus t, and then I'm going to think of this t equals 0 being the spot where the police car takes off. The plot for the police car is x equals 1/2 a t squared plus v sub naught t. He starts out with a 0 velocity, so his speed, he has a 3 meter per second squared acceleration times t squared. So that's going to look something like this. That is the quadratic equation, what it looks like. Then I'll consider what the speeding car looks like. His equation equals vt. He's going at a constant velocity of 24 meters per second. And I'm going to change it so it's vt plus x sub naught. So instead of having the delta x over on the left, I'll have x final minus x initial, and I'll put the x initial over there. So that's going to be plus x initial. Now he was going 24 meters per second, and the police car started 1 second after him. So this is going to be, whoops, I need to make it more like this so that the cop can catch up to him. Sorry, we'll ignore that. This is equation, you can write it in one or two different ways. X equals 24 times t minus 1, and that focuses on the fact that this is minus 1 seconds. Or is it t plus 1? Yeah, it's t plus 1, sorry. Or you can focus on the fact that this crosses this line at 24 meters, in which case you'll have x equals 24t plus 24. So either one of those is good representation. So what is this point? It is the point where 24t plus 24 and 1.5t squared are the same. So I'll go ahead and write that out as 1.5t squared equals 24t plus 24. This is going to have actually two solutions. What happens is that this thing is going to come up on this side too. The equation for 1.5t squared is going to come up here and cross that line there too. But there's going to be one solution that is less than 0 and one solution that is greater than 0. So we can say, let's mention this. T is greater than 0 right here. And we can mention this too if we wanted, t is greater than -1, because that's when the the policeman saw him. Anyway, let's solve this equation. This is a quadratic equation, which means it's kind of ugly to solve. I'm going to first write it as 1.5t squared minus 24t minus 24 equals 0. Once you get a quadratic in this form, the answer is t equals -b plus or minus square root of b squared minus 4ac all over 2a. That means, in this case, -b is positive 24. I'm going to make it a little bit simpler on myself by first multiplying everything through by 2. So it'll be 3t squared minus 48t minus 48 equals 0. That'll get rid of that 1.5 for us. So -b is positive 48. 48 plus or minus the square root of b squared is 48 squared minus 4 times 3 times -48. So 4 times 3 times -48. And I'm going to go ahead and multiply negative times negative, so that gives me positive. And then all of that is divided by 2 times 3. The 2a is 2 times 3. And that is going to be t equals one of these two numbers. The positive here is going to be over on the right hand side. The negative here is going to give you this solution. So I'm going to find what's under the square root first. So 48 squared plus 4 times 3 times 48 is 2,880. And then I'm going to take the square root of that. And I got 53.66. So 48 plus or minus 53. I'll just write 53.7 divided by 6. And we want the positive answer. You can see 48 minus 53.7 will give us a negative answer. So I'm going to take that and add plus 48 equals, and then divide it by 6. And I got equal to 16.9 seconds. Coming back, how long does it take the trooper to overtake the speeding car? It looks like that should be the answer to part A. Now, part B is how fast is the trooper going at that time? For that, I will go ahead and use our usual way of, or my usual way of doing this, which is to separate things out, V, V, A, X, T. Figure out which ones we have, which ones we don't have. We've got 16.9 seconds. We've got the trooper is accelerating at 3 meters per second. We've got his initial velocity was 0. And that should be enough to find this velocity because we have 3 things. And our answer will be velocity delta V over delta T is equal to the acceleration. That's our VV-AT equation. For this one, V final is equal to AT, which is 3 times 16.9, or 50.7 meters per second. And that is really crazy fast. You can look inside the front cover of your book. You see 1 meter per second is 2.237 miles per hour. So put meters per second on the bottom, 2.237 miles per hour, and you get that number times 2.23, come on, 50.7 times 2.237 is 113.4 miles per hour. So he is endangering himself to catch up with that speeder in 16.9 seconds.